Hello students, now we'll start with the next chapter, that is chapter number 10, Wave Optics. In introduction part, we have that the various theories regarding nature of light, that is based on the nature of light and its behavior, we have various theories. First one is the Descartes and Newton's corpuscular theory. This was the first theory, and in this theory states that the light is made up of a very small particles like corpuscles. And according to this theory, the speed of light in the denser medium is greater than that of the speed of light in the rarer medium. But it was proved wrong. So after this we got the another theory, that is Huygens and Fresnel's ether wave theory. According to this theory, the light is a periodic disturbance transmitted through a medium in the form of waves. But after this also we got some other theories, that is the Maxwell's electromagnetic wave theory. According to this theory, the light is an electromagnetic wave which consists of a mutually perpendicular time varying electric and magnetic fields which are also perpendicular to the direction of the propagation of light waves. And this diagram shows the Maxwell's electromagnetic wave theory. But after this we have the another theory, that is Einstein's quantum theory. Einstein used the Planck's quantum hypothesis of black body radiations, and he created his own theory, that is Einstein's quantum theory. And according to his theory, the light consists of packets of energy known as photons. And with the help of this theory, the photoelectric effect and Compton effect were explained. But this theory failed to explain the interference, diffraction and polarization phenomena of light. And next we got the de Broglie's theory, or a dual nature of light. De Broglie's theory, it is concluded that the lights have a dual nature, that is light can be in a particle also and in a wave form also. That is shown by the de Broglie's theory, that is de Broglie's theory of dual nature of light. And this theory was proved correct. And according to this theory, the moving material particle is always associated with a wave known as a matter waves or a de Broglie's wave. He said this also. And by this theory we got to know that the light is having a dual nature, that is it can be in the form of particle also or else it can be in the form of wave also. And next we have the Huygens principle. Before to go in the Huygens principle, we need to know some definitions like wavefront. Wavefront is defined as the locus of all the particles of a medium vibrating in the same phase at a given instant. It is the set of the all particles of a medium vibrating in the same phase at a given instant. It can also be defined as it is the surface over which an optical wave has a constant phase. That is, there is no any phase difference in those waves, and that is known as a wavefront. And we have three types of wavefronts: spherical wavefront, cylindrical wavefront and plane wavefront. And these are due to the sources of that waves. If a point source is there, then that will give us a spherical wavefronts. And if a line source is there like this, and then we will get a cylindrical wavefront. And if a source is at infinite distance, then we will get a plane wavefronts. These regarding the wavefronts. Next we have a Huygens principle. According to this principle, see, each wave of a light is a center of disturbance from which waves spread in all the direction all the particles equidistant from the sources and vibrating in the same phase lie on the surface known as a wavefront. And next, every point on the wavefront is a source of a new disturbance which produces secondary wavelets. These wavelets are spherical and travel with the same speed of light in all the directions in that medium. And next we have only forward envelope closing the tangents at the secondary wavelets at any instant gives the new position of wavefront. The explanation of this, we can see that the explanation. Let S be the solid point source of a light. See, this S point will be the point source of light which sends the disturbances with the spherical symmetry in a homogeneous medium around it. So it is sending some wavefronts or waves, and according to the, let F be the position of a spherical wavefront at t is equal to 0. At time t is equal to 0, this F, the middle line, be the position of that wavefronts. Next, according to the Huygens principle, every point on the wavefront is considered as a center of secondary wavelets. See, Huygens principle, in general we can say that all the points of a wavefront of a light in a vacuum is a source of secondary wavelets which spreads forward at the same speed of light. At each point on that wavefront, that is acting as a secondary source of the secondary wavelets. This each point acting as a sources of secondary wavelets. See, according to Huygens principle, every point on this wavefront, which one came from that the nearer source, that each point is considered as a center of secondary wavefronts. So at time t, each secondary wavelet will travel, right? Secondary wavelets means after this, whatever the wavelets coming from this source, that those are the primary wavefronts, and when they reach certain distance or a certain path, this one, after that whatever the wavelets comes from these points, those are the secondary wavelets. And in Huygens principle, it is saying that each of the points on these primary wavefronts are acting as the sources of secondary wavefronts. So after time t, each secondary wavelet will travel the distance, that is v into t, where v is the speed of a light in that medium and t is the time. So now by taking every point on as the center, draw spheres each of the radius v is equal to v into t. See these points, whatever the centers are there, by taking them we are drawing the circles. See these circles with the radius of v into t. Now see, draw the tangents on the every sphere. Tangents means these are the lines which are touching the spheres at only one point. See, for this sphere there is only one point touching that line, that F2 line, and for each of the sphere we have drawn the each one tangent, and we have closed with that. We have combined and make as a envelope. See, draw the tangents on each sphere and join them by freehand. An envelope F2 enclosing these tangents is the position of wavefronts F after time t. After some time t, this envelope F2, whatever this line is there, that F2, that is the position of the wavefront after time t, that is F2. And this is the regarding Huygens principle. The main principle states that all the points of a wavefront of a light in a vacuum is a source of secondary wavelets which spread forward at the same speed in that medium.